Welcome to our factory. Today, I'll show you how high-speed trains are made. Unum, step by step.
This state-of-the-art facility is where engineering meets aerodynamics to build the future of travel. These machines are designed to travel at over 300 kilometers per hour, safely and smoothly. Every single curve and component is meticulously planned in our digital design center before physical production. Now that the digital blueprint is complete, it is time to move to the factory floor and begin construction. The process starts here. We use lightweight but incredibly strong aerospace-grade aluminum alloys. Before any cutting happens, lasers scan the raw materials to ensure there are zero structural flaws. Overhead cranes seamlessly transport tons of metal to the primary cutting stations across the floor. Precision water jets cut the aluminum plates into exact shapes without warping the metal with heat.
These precisely cut panels will eventually form the skeleton and outer shell of the train carriages.
Meanwhile, in the forge, high-carbon steel is being heated to create the train's critical wheel sets. A hydraulic press applies thousands of tons of pressure to forge the steel into perfectly round wheels. The wheels slowly cool down as they travel along the line, ensuring maximum structural integrity. Once cooled, computer-controlled lathes shave off millimeters of steel to achieve a perfectly smooth rolling surface. Hundreds of perfect wheels stand ready to be integrated into the train's undercarriage. The axles, which will connect the wheels, are polished to a mirror finish to reduce friction. Automated vehicles navigate the factory floor safely, transporting the heavy steel components to the next phase. Every single dimension is verified down to the micrometer to prevent any vibration at high speeds. With the raw materials prepped and shaped, we have all the building blocks ready for construction. Our inventory management system ensures that every part is delivered to the exact right station on time. Welcome to the welding bay, where the flat aluminum panels are joined together to form the train's shell. Robotic welders execute continuous, flawless seams that human hands simply cannot replicate. Quality control happens immediately. Inspectors use ultrasound to ensure there are no internal air pockets in the welds. The roof panels are welded on from above, enclosing the basic structure of the passenger car. This synchronized process allows us to build multiple carriages side by side, maximizing efficiency. For the floor support, we use extruded aluminum profiles, which provide immense strength with low weight.
Cranes gently lower these reinforced floors into the hollow frame of the carriage.
Technicians secure the flooring using specialized pneumatic tools that apply the exact required torque.
Once the core shell is welded and bolted, it is lifted and moved to the next production zone.
Now we look at the most iconic part of the train, the aerodynamic nose cone. The nose is milled from lightweight carbon composite materials to reduce drag and save weight. Layers of advanced composites are carefully applied and cured to give the nose its incredible strength. The entire front section is baked in a massive oven to harden the composite materials. Precise temperature control ensures the carbon fiber cures without warping or weakening. Out of the oven comes a perfectly smooth, aerodynamic marvel, ready to slice through the air. Even in a highly automated factory, the final polish of the nose cone requires a delicate human touch. Central control constantly monitors the workflow, ensuring no bottlenecks slow down the production line. These hollow aluminum tubes are now structurally complete, and incredibly rigid. Next, we need to give this empty shell the power to move and the wheels to roll upon.
This is the bogie assembly area. The bogie is the complex chassis that holds the wheels and motors.
The high-carbon steel wheel sets we forged earlier are now carefully mated to the bogie suspension frame. Dual suspension systems, using both steel coils and compressed airbags, are installed to ensure a smooth ride. Every bolt on the bogie is tightened by computer-controlled drills to the exact safety specification. Now, the heart of the train, the electric traction motor, which will generate thousands of horsepower. High-voltage cables are securely connected to feed power directly from the overhead lines to the motors. Stopping a train at 300 kilometers per hour requires immense power. We use magnetic track brakes. Each completed bogie undergoes rigorous testing before it is ever attached to a train car. In a process known as the marriage, the lightweight shell is gently lowered onto its powerful wheel chassis.
Heavy-duty locking pins secure the carriage to the bogies, creating a unified, unbreakable structure.
For the first time, the train car is rolling on its own wheels down the production line.
Underneath the floor, technicians meticulously install kilometers of electrical wiring and data cables.
These nerve centers control everything from the braking system to the air conditioning in the cabin.
To reduce drag, smooth aerodynamic panels are bolted over the complex mechanical underbelly.
On the roof, the pantograph is installed. This robotic arm will draw electricity from overhead power lines. The contact strip is coated in special carbon to conduct extreme voltage while gliding friction-free. The folding mechanism is tested to ensure it maintains constant pressure against the power lines at high speeds. With the core mechanics and structure finalized, the train is ready for its exterior finish. Welcome to the paint shop, a pressurized, dust-free environment designed for flawless application. Robotic atomizers apply a specialized base coat that protects the aluminum from extreme weather conditions. The iconic colors are applied with mathematical precision, symbolizing speed and modernity. Specialized human painters detail the intricate areas around the doors and windows to ensure perfection. The fresh paint is instantly baked onto the metal in a tunnel of high-intensity infrared heat lamps. The infrared baking creates a high-gloss, ultra-durable finish that will withstand years of high-speed travel. Emerging from the oven, the train finally looks like the high-speed marvel it was designed to be.
Workers remove the protective masking to reveal the slots where the panoramic windows will be installed. Automated suction arms lift the heavy, double-paned safety glass, designed to withstand severe impacts. A heavy layer of industrial sealant locks the glass into place, making the cabin completely airtight. The exterior is now 100% complete. It is time to turn our attention to the inside.
Inside, the carriage is still an empty aluminum shell. The interior assembly is a highly choreographed process.
First, thick layers of acoustic and thermal insulation are packed into the walls to guarantee a quiet ride.
Next, modular interior panels are snapped into place, covering the wires and insulation with a clean look. Energy-efficient LED lighting systems are installed in the ceiling, capable of changing color temperatures.
Automated transport carts arrive right on schedule, delivering the ergonomically designed passenger seats.
Each seat is securely bolted into specialized tracks embedded in the floor for maximum safety.
The seats are upholstered in durable, fire-retardant materials designed for absolute long-distance comfort.
Digital information displays and high-speed Wi-Fi routers are installed throughout the cabin.
The automated glass partition doors are rigorously tested for smooth, silent operation. The passenger cabin is now a modern oasis, blending high technology with passenger comfort.
Now we enter the most complex space in the interior, the driver's cockpit inside the aerodynamic nose. Engineers carefully maneuver the primary control console into place, the brain of the entire train. Hundreds of data cables are connected to the central computer, giving the driver total control. The driver's seat is heavily damped and ergonomically designed to reduce fatigue over long journeys.
This single lever controls thousands of horsepower, allowing the driver to accelerate or stop smoothly.
Power is connected. The onboard computers boot up, running millions of diagnostic checks in seconds. Between the carriages, hydraulic buffers and specialized couplings are installed to link the train together. A flexible rubber gangway creates an airtight seal between cars, reducing noise and wind resistance. Finally, the individual carriages are physically and electronically linked to form one complete high-speed train. The entire train now acts as a single, incredibly aerodynamic organism, ready for the tracks.
Final safety decals and manufacturer badges are applied by hand, marking the end of the assembly line. A symbol of engineering excellence, this train is almost ready to carry its first passengers. Inside, the protective plastics are removed, and a meticulous cleaning process begins.
Visual inspectors walk through every inch of the train, checking for the slightest cosmetic imperfection. Every moving part, down to the tray tables and armrests, is tested for durability and smooth action. Even the onboard lavatories feature aerospace-style vacuum plumbing for maximum hygiene and efficiency. The cabin lighting system is tested, ensuring it can create a relaxing atmosphere for any time of day. A final layer of waterproofing ensures that the high-pressure cabins remain sealed in any weather. Assembly is officially complete. But before it leaves the factory, it must pass rigorous quality control. The train enters the simulation chamber, where we artificially create the harshest conditions on Earth.
Hurricane-force winds and torrential rain are blasted at the train to ensure absolutely zero water leakage.
Inside, engineers use thermal cameras to verify that the insulation and window seals are performing perfectly.
Next, the temperature is dropped below freezing to test the heating systems and mechanical tolerances in winter conditions. Once climate testing is passed, the train's software and electrical grid face millions of simulated scenarios. The engines are pushed to their absolute limits on a stationary track, simulating speeds of 400 kilometers per hour. Sensors detect even microscopic vibrations. If the train isn't perfectly smooth, it does not leave the factory.
Having passed all indoor simulations, it is time for the final exam, the outdoor test track.
The train rolls out into the sunlight and immediately begins acceleration testing on the private factory rail line. Inside the cockpit, test pilots verify that the automated safety systems and manual controls are perfectly responsive. The advanced suspension dynamically tilts the carriages into the curves, ensuring passengers won't even spill their coffee.
The data is in. The train has passed all safety, speed, and comfort requirements with flying colors.
Here in the dispatch yard, these marvels of modern engineering await their journey to cities around the world.
From raw aluminum sheets to a 300-kilometer-per-hour bullet, the transformation is truly spectacular.
These factories never sleep, constantly pushing the boundaries of technology to connect the world faster than ever.
Thanks for touring the factory with us today.
If you enjoyed seeing how it's made, don't forget to like and subscribe.